What does modernization of equipment and machinery mean in a mining context? Well, just like the rest of the world, modernization is increasingly meaning data, the collection of data, its processing, and decision-making based on that data. Ore sorting is an excellent example of data colliding with machinery that's already used in mining. Sensors, like the one that is shown in the video here, are used to collect information about the quality of ore. That quality information is processed and compared to economic and technical models, and then downstream equipment like the flop gate diverter shown here are used to execute decisions based on that data and that information. Hello, I'm Chris Beale, CEO of Nextor, an Australian company that manufactures and supplies sophisticated magnetic resonance sensing and sorting solutions to mining companies all over the world. Magnetic resonance is a new technology to the mining industry, but it's actually being taken up rather quickly for an industry that is so well known for being averse to technology and change. And today, I will be going through a presentation that steps back a little bit from the technical aspects of magnetic resonance technology and focuses more on the experiences that we've had with our customers and the challenges that they're seeking to overcome by using bulk ore sorting and magnetic resonance technology. So if we go back to the presentation, I will quickly go over the nature of the magnetic resonance technology because it is fundamentally different from technologies that have come before. The easiest way to think about an MR sensor is imagine taking an MRI machine out of a hospital environment or medical environment and installing it around a conveyor belt or over a truck at a mine site. That donut is an antenna, and it projects radio waves that are tuned to the target mineral that we're looking for, the resonant frequency of that target mineral. And those radio waves will generate a response from that mineral, and that response is again measured by the antenna. The strength of the signal that is received by the antenna is proportionate to the quantity of that mineral that's in the ore. It's a direct linear response. There are a lot of benefits to this technology, but it's best considered to be the scalpel approach of sensing. Our analyzers are designed to measure one or maybe two minerals at a time. But the benefit that's derived out of that is that you gain accuracy, you gain speed, and you gain confidence in the measurement that's being produced. These analyzers have been demonstrated in the field to operate 15 times more quickly at competing accuracy to any existing sensing technology for bulk sensing. And furthermore, these pieces of equipment are tuned in our factory before they're sent to a mine site and not impacted by changing ore types or changing host rock types or trace elements. And they will continue to produce accurate measurements consistently. We have never had to recalibrate an analyzer that's been mobilized into the field. There are other benefits as well. This is a deeply penetrative technology, and so it is quite capable of dealing with very coarse and very fine material, as you'll see. There are health and safety benefits because this is a radio technology and therefore non-ionizing radiation, no regulations to adhere to. And the speed, this ability to measure accurately in 2, 3, 4 seconds means that the associated capital equipment that's needed to carry out bulk sorting can be very compact and in fact is being turned into mobile solutions. So we'll return to the presentation here. This map shows the locations of MR analyzers and bulk sorting plants that have or are being deployed into the field at the moment. And today we will be going through 3 copper mining operations where the equipment is being used to generate a benefit for the project. The first case study is from a Mexican mine called the Cozamin Mine, owned by Capstone Mining Corporation, a TSX-listed mining company. This is an underground high-grade copper zinc mine. The mining rate is about 1.6 million ton per annum, and accordingly this plant has been designed for roughly 200 to 400 tons per hour of feed. The actual detailed outcomes of this project have been covered in a technical paper and a case study that was recently released at the AusIMM Pre-Concentration Conference. And if you're interested, I would suggest that you go watch the video of that and review the technical paper, because it does have a great deal of detail. But effectively, the challenge that this client was looking to overcome, and obviously this is shown as a surface plant, but it's designed to fit the specification that would work underground, albeit with a shorter conveyor belt. But the intention is that the ore that's mined at this operation, that's pulled out of stopes and development headings, goes to an underground crushing system and then is hoisted to surface using 2 4-ton skips. That represents a potential bottleneck for the mine, and if there is the ability to pre-concentrate the ore before it is hoisted to surface, then that represents a better use of capital equipment and the ability to produce more metal from an existing piece of plant or piece of capital equipment. At this mining operation, or at this project, the outcomes were that the feed grade of 1.1% copper was improved to 1.43% copper. The material rejection was 30% of the feed, and interestingly, there was a net metal recovery improvement from the use of this of between 6 and 8%. And if that sounds somewhat counterintuitive, I would recommend that you go and have a look at that paper, because it is discussed in detail how that is achieved. Second case study is an open cut copper operation, and it is at a much larger throughput than the Cozemin plant previously shown. This is designed to operate at 2,500 tons per hour of feed, and the intention here is that we will retrofit a magnetic resonance analyzer onto the conveyor belt between the primary crusher and the coarse ore stockpile shown here. This allows the company to be very capital efficient in deploying a bulk ore sorting solution. And the intention, in terms of the challenge that is being overcome using the technology, is to assist with geological confidence effectively and improve, again, the metal recovery from the mining operation. Now, this is a geologically complex ore body, and it is practically unachievable for a geologist to be able to review and very carefully evaluate each ton of ore that comes out of the mine. And so that's exactly what this bulk ore sorting plant is used to achieve. If there is ore that is produced from the mine which is either marginal or which is in the category of being potentially high or low grade, rather than having to do detailed modeling of it, or in addition to detailed modeling, I suppose, you can send all of that material through the crusher and to this bulk sorting plant and allow the on-stream analyzer or the on-conveyor analyzer to determine what is the valuable and waste material and divert that material. In the third case, again, an open cut copper mine, this time in the Philippines, and at a throughput rate of 1,000 tons per hour. This is a historical mining operation that began operating roughly in the 1950s, and there is a substantial resource still remaining. But the high-grade core of the ore body has been depleted to some extent, and more and more marginal or low-grade ore as a proportion of the total mining ore is being produced from the mine. The intention here is that this increasing proportion of marginal material, rather than being dumped onto a low-grade stockpile or even worse, onto a waste dump, can be fed to a bulk sorting plant where it can be upgraded, and the valuable mineral and metal that's contained in there can be fed to the processing plant without displacing other high-value material. This allows you to avoid a costly plant expansion and the associated increase in electricity and water consumption and tailings production that would come with it, while still being able to generate more metal from the existing operation. This project in particular is very interesting. Our partners, CD Processing, have financed, designed, and are building, owning, and operating this bulk crushing and sorting plant, which will take the marginal material produced from the mine, crush it, upgrade it, and then feed it right into the processing facility. And the mine, obviously, again, this is a very capital efficient way of achieving a bulk ore sorting outcome. And they pay on a per ton basis for that to occur. So that is a very brief summary of a couple of different, again, challenges that our customers have run into and which they're looking to overcome with bulk ore sorting. Thank you for your time, and if you have any questions, I'd be very happy to have them, and I look forward to speaking to you further. Thank you.